Hello, welcome. In this short video, let us look at an example illustrating how we can use numerical simulations to verify whether a system is linear or not. So let us look at the example of zener diode. So we want to use numerical simulations to check the linearity of a system. So consider the example of zener diode. So the system for this zener diode can be defined as x of t is equal to value 0.5 for the input voltage V of t greater than 0.5, and it is equal to minus 0.5 when V of t is less than minus 0.5 and equal to V of t elsewhere. So given this definition of the system, we want to verify whether this is a linear system or not by using numerical implementation or numerical simulation. First, let us look at the input and output of the system for a given V of t is equal to cos of pi t for values of time between 0 and 5. For this given input, let us look at the input and the output plots. So this section of the Python code where we basically define the x-axis, that is the time vector, and then the input vector V of t, and then the output x of t. So clearly the blue dotted line is the input, that is basically a cosine signal, and then this is the output of the zener diode, which is basically like a clipper, that is it basically removes any output that is absolute value is greater than 0.5 and reduces or restricts the output to value of 0.5 or minus 0.5 depending on the sign of the input. So this is the input and output plot for the given system. Now let us verify whether the system is linear or not. So to verify that, consider the input V of t is equal to a times V1 of t plus b times V2 of t. That is a linear combination of two possible inputs or two different inputs. Then the corresponding output x1 of t is equal to 0.5 when this sum, that is a times V1 of t plus b times V2 of t, is greater than 0.5, and minus 0.5 when this sum is less than minus 0.5 and is equal to the sum when elsewhere. That is when the value of the input is less than, the absolute value of the input is less than 0.5, then the output is equal to the input. So this is the corresponding output when a linear combination of V1 and V2 is given as input. Now the output x2 of t given as a linear combination of corresponding outputs, that is x1 of t will be the output when V1 of t is the input from the original definition of the system, and x2 of t will be the output when V2 of t is the input. So clearly we can intuitively see that x1 of t is not going to be equal to x2 of t because the values for which this sum is greater than 0.5 will be different from the values for which this sum is greater than 0.5, the output is 0.5, but for the same values there is no guarantee that this sum is going to be equal to 0.5. So that is one intuitive way to decide whether x1 of t is equal to x2 of t. But we can actually use the numerical example to have a better understanding of whether the system is linear or not. First, we define two signals V1 of t and V2 of t, basically with two different frequencies for a sinusoid, and then we basically add them using weights of 1/3 and 2/3. Then you have a new combined input, a linear combination of the two inputs V1 of t and V2 of t, and then we look at the input Vt underscore c, which is basically the combined input, and then we develop both x1 of t, that is we basically compute x1 of t and x2 of t. x2 of t is the linear combination of the corresponding individual outputs, and x1 of t and xt1, that is the output when the combined input is given. So let us look at the final result. This plot shows the combined input, that is Vt of c, that is Vt underscore c, and then we have two different outputs, that is the red one corresponds to xt1, that is the output when the combined input is given, that is when we use the combined input, that is the linear combination of the inputs, and the green one is the output when you add the corresponding outputs, that is corresponding individual outputs. So clearly they are not same, that is the system is not linear. Again we can clearly see that for the xt1, that is the output for the combined input corresponding to the combined input, the values are clearly equal to 0.5, that is the maximum values are clearly equal to 0.5 or minimum values are clearly equal to -0. But for the output x2 of t, which is basically a combination of the corresponding individual outputs, the maximum values need not be 0.5 or the maximum need not be 0.5, because there is no guarantee that for the same values, that is for these values, there is no guarantee that the sum is going to be 0.5. So that is what is illustrated by this plot. Thus we can use numerical simulations to verify whether a system is linear or not. Thanks for watching.